Previously, we saw the general aspects of the query objects, the components in its structure, and the way to see it in runtime through the use of the query viewer control. Now let's focus on presenting a series of examples where we will increase the complexity of the query design so that we can learn more about the scope of this GeneXus object. As we've mentioned before, the elements that define the query appear under the Attributes node, and an extended table must exist for containing them all. That's why we can then declare attributes, aggregation functions, either simple or conditioned, and expressions. Let's see the design for this query. We want to see the number of tourist attractions for each city, and we also want to view this information in the form of a dynamic table. In defining a query, an attribute may be considered with aggregation. This corresponds to numeric attributes with decimals, sum, count, and average. And without aggregation, this corresponds to descriptions, dates, and numbers with no decimals. Therefore, this determines its position within the dynamic table, either as an axis or as data. Axes are elements that allow pivoting, and they are automatically associated with attributes without aggregation. On the other hand, data are elements that are added according to axes and are automatically associated with attributes with aggregations. Let's see the preview of our query object. We can then pivot by city name and country name, which are not the axes, and thus be able to resort the same information in different rows and columns. Now let's analyze this new query returning, for each customer, total amounts relative to reservations, the number of reservations made, and the daily average of reservations. As the result of a query, we may obtain data in the form of three different aggregations: sum, to add, count, to count, and average, to find an average, all of which may be nested. We should note that, specifically, the average function admits a by clause to determine the criterion based on which the average is made. Here we have the preview of the query in the form of a graph. Now let's see a new example and compare the design of the two queries. In the first example, the reservation price of all the reservations held by the customer are added and then divided by the number of reservations. In the second example, reservations are grouped by date, and the sum of reservation price is divided into the number of date groups. That is to say, the average is calculated according to the number of different dates. In this case, we need the by clause to achieve that grouping. Here we have the preview of each of these queries to compare results. Now let's analyze a new example. In the first case, from among all reservations of one customer, only those exceeding $200 will be added. In the second case, however, the customers that are shown will only be those whose reservations add up to over $200. Let's also compare the different results. Now let's focus on filters. As mentioned, there are several types. They could be ranges, lists, using the like operator, using subqueries, with the possibility of defining any nesting level for these filters, and to then parameterize them with defined parameters. Two types of filter groups are available: and or. In the example we see here, we've already defined a group of filters whose elements are united by the OR operator. Now we will define a new group. We right-click on Insert Filter Group and declare that these elements will also be united by the OR operator. We will declare that the customer has reservations available and that the date of the reservation must be later than today. The final result that comes about from this query will then be derived from applying the OR operator declared in each group to finally apply the main operator AND. To this point, we've presented different examples of dynamic query design, and we've seen the output through their preview. We should recall that, in order to view the output of a query object in runtime, we need to create a web panel and insert user control query viewer. When we insert a query viewer control in an object's web form, as is the case with most user controls, certain SDTs are consolidated in the KB, some enumerated domains, and variables based on those types are created in the object. Also, code lines are added as an example to help in configuring the properties. In this way, the developer would only have to use them. If we go back to GeneXus, we can see some examples. We want to view in runtime the query that shows the number of tourist attractions by city. So we create a web panel called WP Query and drag user control query viewer from the toolbox. To view the query as a graph, we can directly indicate the name of our query object in the object property of the control. And declare the output as chart type. But if the end user wishes to have the option in runtime as to the way in which the query is viewed and does not declare previously and in a static manner, then we will have to set some properties in runtime. Our first step was to define in the form of the web panel a combo box to allow the user to select the form of the output, and we inserted a button. Now let's analyze the associated enter event. To the type property of the query viewer, we are assigning the value selected in the combo, and we also indicate that when the chart option is selected, it is to be viewed as a column 3D graph. Now let's see its behavior in runtime. We press F5. Then we select the WP Query web panel. And we can pivot to view the data sorted in a different way. Select the output as a static table or as a graph that will be seen in 3D columns. And lastly, we will see an example that requires passing parameters. We want to have the possibility of selecting a specific country in runtime and graph the number of tourist attractions per city. We've also created the following web panel called Attractions per Country, where we can select a country from a dynamic combo. Let's analyze the properties of the query viewer control, and we will see that in the parameters property, the parameters variable has been associated. This variable is based on the query viewer parameters SDT, created automatically when the query viewer control is dragged. And it corresponds to a collection of parameters where each has its own name and value. If we go back to the web panel, we can see the enter event associated with the button. Both variables, parameters and parameter, have been created automatically in the web panel when the query viewer was dragged. In the case of the parameter variable, it represents an element in the collection of parameters, while the variable parameters represents the collection of parameters. So we analyze both variables and associate to variable parameter the name and value corresponding to the parameter we use, country ID, bearing in mind that due to the structure of the SDT, the elements must be of the character type. Then we add the parameter to the collection. And lastly, we associate the output as a graph, specifically as 3D columns. All that remains is to associate the query object to the query viewer control, associating to control query viewer 1 to the object name property, the name of our query object. Now let's see the behavior in runtime. We press F5. and select Attractions per country.